how the landforms are formed. But before that, we need to understand what landforms are. So landform is basically that particular shape which we are analyzing, but it is caused by certain agents and processes that we have to study here. What the present landform is an outcome of the balance between those processes which are creating them and the ones which are destroying them. Wind is blowing. Within the wind, there are a lot of sand particles that are present. They are colliding with each other. Now, collision with each other leads to formation of further finer particles. This is known as attrition. Now, sand dunes, when I talk about, basically refers to heaps or mounds of sand. And those mounds and heaps of sand are arranged in various ways. And because of that, they are given various names. Whatever material was present here is eroded because that was of softer nature. The role of the surface water as well as the groundwater plays a very important role in creation of such structures which you are going to see. Hello aspirants, welcome to PW Only IAS. I am here Harpreet Singh with another lecture from the Physical Geography series. This is lecture number 6, that is landforms and their evolution. Now please understand students, whatever we had studied in the previous chapters, particularly the geomorphic processes, becomes very important in the understanding of the chapter of landforms, how the landforms are formed. But before that, we need to understand what landforms are. Along with it, there are a lot of geomorphic processes and agents which are shaping these landforms, like wind, like running water, glaciers, groundwater, and so on and so forth. And we're going to study them each one by one, and I'm going to tell you what are the erosional features, what are the depositional features with diagrams. Now, this is something very important. Unlike the NCERTs where they have mentioned a lot of things, but they haven't drawn a lot of diagrams, but you are asked these features repeatedly in your prelims as well as your mains examination. That is why I'm telling you again, even this time there was one feature that was asked with respect to the glacial features and many were not able to attempt. So that is why I'm telling you whatever is being done in this chapter is a very comprehensively it has been covered, and whatever diagrams have been made, those are having made by hand. So it is easier for you also to make them and replicate in your examination. So let us begin with today's chapter, that is landform and their evolution, that is lecture number 6. Now please understand this very carefully. This is a Telegram account where you can find a lot of content on geography, anthropology optional, society, social justice and civil services preparation in general. Now let us begin with the topic that is landforms. Now when we talk about landforms and their evolution, it is also important for us to understand what landform basically means. Landform. Let's leave the definition right now for 2 minutes. When I say land, you by default means we are talking something related to the surface of the earth where land is present. Then form. Can I say a shape that is being taken by that land? Now that shape might be a little bit uplifted, that might be flat, that might be in, let us say, coarse or a crude form. So can I say that shape that is formed or present when I see a certain part of land might be because of certain processes that it might have undergone. And because of that, that particular shape of the land is present. So landform is basically that particular shape which we are analyzing, but it is caused by certain agents and processes that we have to study here. So in simple words, I have told you what landform is, landform, but let's see what is the geographical proper definition when we talk about the concept of landform. Let's see. When we study over here, you'll see landform are natural physical features. Now many will say, sir, there are artificial features also included. Over here, we are not talking about them. Yes, they can be created. There can be amusement parks also where artificial landforms are created. But over here, when you're talking from the perspective of geography over here, we are talking from the perspective that we are taking natural features right now, right? So these are natural physical features on the Earth's surface, such as mountain, plateaus, plains. Now you see, when I talk about mountains, when I talk about plateaus, when I talk about plains, we have done these concepts also in the previous lectures. They have been formed because of certain processes that have taken place. You have studied the fold mountains concept, which I told you. You have seen a lot of processes, erosional aspects also we have done in brief in the previous chapter also. So there are, when we talk about plains, you know it is formed because of the deposition that has taken place, right? So we in a way understand that whenever I see or whenever you see a part of the land, there will be certain structure that might be formed. Let us say features that might be formed, to be more precise. That might be like of a mountain, plateau or plains. Now these are the natural physical features that are present on the Earth's surface, and these are referred to as landforms. Now please understand, they are created or modified over a long period of time by weathering, erosion and deposition. Now see, when we were doing the topic of plate tectonics, you know that very, very well, that on one hand, there were certain processes that were creating new landforms. There were other processes that were eroding them. You have seen them. Now, similarly, that means a landform that is created is an outcome of these processes that are going on. Some processes might be eroding them. Some processes might be creating them. Similarly, if you see whether it is a mountain, whether it is a plateau, you see very often you hear about the word like eroded plateaus. How come? Supposingly the plateaus have been formed due to some, let us say, granitic rocks. Those are due to volcanic eruptions. Let us assume that, right? There can be multiple other reasons also. But those plateaus, let us say, are slowly being eroded by, let us say, wind, let us say, running water. So their shape is being modified. They were created by some forces and agents. They're being destroyed by some of the other forces of agents. So that means what the present landform is an outcome of the balance between those processes which are creating them and the ones which are destroying them. Similarly, see here, because any landform is created or modified. Modified means because the shape might change, the way it is looking, the way it is being depicted might change because of the processes which include weathering, erosion and deposition, right? Now see, evolution of landform implies a transformation. Transformation means change, either in the part of the Earth's surface from one landform to another, or transformation of individual landforms after they have once formed. So in both ways, see, first, there are two things that have been mentioned here. Now, this is important from the NCERT's perspective also, right? That has been mentioned here. Evolution of landform implies transformation. Transformation basically means change. Now, the change can take place and a part of the Earth's surface from one landform into another. Now, supposingly, there is a region where, let us say, a plain region is present, right? Now, due to some tectonic movement, there is upliftment. Now, there is a transformation that has taken place in that region. So, there can be transformation on the part of the Earth's surface. Another, transformation of individual landforms after they have once formed. Now, individual landforms changing. Let us assume there is a rock, huge boulder or a rock that is present. Due to wind erosion, its shape is changing continuously. Or after that, you will see a mushroom rock being created. So, those cases can also happen. So, multiple aspects. In simple words, the thing that lies is the landscape, which are natural physical features present on the Earth's surface, and these are subject to changes, modification, and again, new landscape might be coming because of the processes that take place, which include weathering, which includes erosion, which includes deposition. So this is what landforms basically refer to. Now, when we have discussed about this, you know that in the previous chapter, we had discussed about two aspects along with the weathering and mass wasting, which I had mentioned that erosion and deposition. Now see, let's see here. Something very interesting to note here. Let me tell you something, please understand this. I'm writing certain words over here, and because this chapter is going to deal with this, that is why it becomes very important. Let's see. I'm writing few words. Let us say wind, right? Let us say running water or surface water, right? Let us say groundwater. Groundwater is very intricately linked to the concept of karst topography, that is lies in the region of limestone regions, which we'll be studying, right? You can even have glaciers, etc. Right? Now, do you realize that when I talk about, let us say wind or running water, let us take for the timing these. Do you realize wind in a way is basically eroding certain things also? What do you mean by erosion? Erosion basically means, again, certain rocks, certain landforms might be weathered. That helps in erosion, obviously, but individually also it can happen. What we try to say is acquiring and transportation of the various material basically covers the aspect of erosion, and that being deposited is known as deposition. Now, over here, all these things that are present here have a dual nature, that these include a lot of processes also, geomorphic processes as well as agents also. Because see, wind is going to erode also, wind is also going to deposit also. Running water is going to erode also, running water is going to deposit also. Groundwater is going to erode also, groundwater is going to deposit also. Glacier is going to erode also, glacier is going to deposit also. We have done erosion and deposition briefly in the previous chapter also. That is why these are themselves as processes also and agents also. So they are, that is why are studied under geomorphic processes and also as agents, as geomorphic agents. This was a chart also that I had made in the previous lecture also, because it will include a lot of processes also, and there are agents also which are again eroding also and depositing also. So that is why in this particular chapter, we will be picking up these things one by one, and we will be discussing what are the erosional features, what are the depositional features or landforms that they basically form. This is the whole chapter which in the NCERT deals with. Along with it, obviously, I have added a lot of other words, other explanation, other features which are possibly not mentioned in the NCERT. Why? Because again, NCERT might have just simply mentioned or not explained, so I have explained them. Certain other features have been added from some other books also, just to make it more comprehensive. Clear? Now let's begin with all of these one by one. First is wind. Now everybody knows what wind is. We are not going to see that what wind is, but see, from the perspective of landform formation, this is a very, very important agent, as well as includes a lot of processes. Now, the way I have mentioned, now these are certain things which are mentioned in NCERT also, but they are not explained very well. So what I have done is I've explained them also in form in such a way that you will be able to comprehend and remember them, right? Now, wind. Now, you know that very well, wind is a very dominant agent when it comes to hot desert. Now question will arise in hot desert. Obviously, temperature variations there, winds are blowing, they might be eroding certain rocks that are present there. But how, sir? So there are multiple processes through which they do. That is why I have mentioned all these three processes or ways. So first of all, wind is a dominant agent in the hot desert. This has been asked in the PCS examinations repeatedly in almost all PCS, and in UPSC also it has been repeatedly asked. Wind is a very dominant agent of erosion in the hot desert region. Now, wind erosion generally takes place above the ground, and the wind velocity plays a very major role. Now, please understand, when the wind is blowing, it is not only simply blowing. Yes, there can be normal processes also where wind is blowing, but in most of the cases, you will realize that they pick up small sediments also. And those sediments, again, when they are blowing, those sediments actually in a way attack the landforms also, and that is also like helping in erosion of those landforms and reshaping them, which we will understand over here. Obviously, you see that it is generally taking above the land, above the surface, above the ground, as we said. Now, what are the processes that are involved becomes very important. The wind erosion basically happens or takes place through three ways. First is deflation. Second is abrasion or sand blasting, as it is called. Both words have been used, can be used. Third is attrition. Now, these words have been asked in the civil services also, in the prelims, as well as PCS multiple times are asked. Now, how these processes take place and what they are, this should be understood very well, because in the civil services, they can possibly give you match the following, and possibly if you do not know these processes well, you will not be able to even answer them. And in mains also, very easily they can ask you. Now see here, let us see deflation. What do you mean by deflation? It is the process of removing, lifting, or blowing away dry and loose particles of sand and dust. So that means when the wind is basically removing, lifting, or let us say blowing away the loose material that are present because of the velocity of the wind, it is known as deflation, right? Now, this is the concept of deflation. We will be studying them in the application perspective also, then you will be better able to understand. Right now, just understand the definition. Supposingly, there's a certain, let us say, rock that is present. It has certain loose particles that are present. Or for that matter, let us say normal surface is also present in a, that is sandy surface is also present on the desert region. The wind is coming at a very fast pace. From, let us say, certain particles that are present on the rock surface also, which are loose, it might be blown away from, in a way, detaching also, removing from the surface also, from the rock surface. Or they might be lying, if the sand particles might be present in the desert, then also they are picked up. Either case, the concept is basically they are removed, lifted, or then taken away by the velocity of the wind. That is known as deflation. Next comes abrasion or sandblasting. Now see, this is a very interesting concept. Abrasion means that the wind-driven sand particles strike against the rock surface and wearing them down. You will be saying, sir, aren't we going to see the diagrams of this? Beta, please understand, when I will be going here, we will be seeing a lot of processes. So everything is covered here. All the dimensions which I have made here with respect to all the features will be present here. So don't need to worry. Right now, just understand the concept. I'll be explaining you again, don't worry. Abrasion basically means that the wind-driven sand particles strike against the rock surface and wearing them down. It involves rubbing, grinding, and polishing. Now let us assume this. Let's take an example. Supposing this is a small rock structure that is present in a desert, right? Supposing this is a wind that is coming, right? Now this wind has, now see, supposingly this wind is coming here. Now see like this. Now over here, wind has picked up certain sand particles. Now this wind carrying sand particles are coming and striking here. Now when they strike this down, it is going to wear this down also. It is going to, in a way, erode also. So remember this abrasion. Why it is known as abrasion or sand blasting? This is the reason. That means that the sand particles or the sediments that are being carried by the wind are striking, because the wind is blowing them. They're going to strike the another surface or another landform, and which is going to wear it down. Now this repeated rubbing, in a way, that is why it is known as rubbing, or in a way polishing, might giving a little bit shine also. Why? Because see, you would have seen when you are rubbing certain thing down, if you're reducing the friction, it will lead to certain shine also. That is why they have mentioned the rubbing, grinding, and polishing the surface. I'll be showing you a diagram also, so don't need to worry about that. Attrition. Attrition is a process by which rock fragments and sand particles carried by the wind collide with each other and form further finer particles. Now, what does it mean? Supposingly, wind is blowing. Within the wind, there are a lot of sand particles that are present. They are colliding with each other. Now, collision with each other leads to formation of further finer particles. This is known as attrition. Let us see it in certain, let us see, make certain diagrams of this. You have this, I've made a copy of this. Let's see this. Okay, now let's see. When I'm talking about deflation, let's see deflation. Supposingly, this is a surface. You know that during the time when you're talking about hot desert region, there's continuous temperature variations during the daytime. It's very hot. During the time of night, it is cold. So obviously, there are a lot of cracks that might develop in the landform. So you might assume that there are certain cracks might be developing and certain particles might have broken down here, like this. Now, in this process, we realize that wind blows. Wind is blowing. What it will do is, do you see the particles which were present here? The particles which were present here, in a way, see here. I'm putting small particles over here which are reflecting that they have taken, these particles have been taken by the wind. So the particles have been picked up and taken by the wind. So that means process of removing, lifting, blowing away of the dry and loose particles of sand by wind. So it has been taken away. So what does this mean basically? So what does this mean? This basically refers to the aspect where the wind, due to its velocity, blows away, picks other, let us say, sand particles or dust particles away because of the velocity. This is known as what? Deflation. Now comes abrasion and sandblasting. Now let us see here. Supposingly this is a surface of a, supposingly this is a rock that is present. Let us say, right, let us say landform that is present, a large landform that is present, a large rock structure is present in the desert region. Now, what happens is, wind is blowing. Now, people will say, sir, you had mentioned that erosion takes place above the ground surface, not very high also. The reason being because when they are carrying the sand particles, they also have a weight. So there is a restriction to which level or a height the wind can take or carry. That is why generally they are close to the ground surface. Now let us assume they are basically carrying these particles which they had picked up from here. Slowly, what will happen? There is a possibility that depending upon the rock structure also, please remember this rock structure also. Now this is the eroded surface. I think on the color might not be visible, so let me change it. Eroded surface. Why? Because over here there is wearing down that is taking place because of the particles which were being carried by the sand. When I'm talking about attrition, now please understand this is again a very interesting process. Supposingly the wind is moving. Supposingly the wind is moving here. Now what happens is there are particles. Let these particles are present here, right? Now what we are trying to tell you is these particles are colliding with themselves, with each other, sorry. They're colliding with each other, and that is why the sediments which are present become further more fine because of the collision that is taking place. This is known as attrition. So now what is clear to you? See here. We have done with the three processes, deflation, abrasion and attrition, and I've drawn a little bit rough diagrams which you can draw in your examinations also. Clear? Okay. Let's move ahead. Though the rains is scarce in desert, but it comes down torrentially in a period of time, and the weather debris in desert is moved not only by wind but also by rain and rain also. What happens is sometimes you know that obviously the frequency of rain in the desert is again very low, very rare. But when it happens, obviously it might also be contributing towards the erosion in the desert. So that is what is being said. Why I have mentioned this statement? Because it is very, very important, present in the NCERT. And over there questions might be asked which will mix the question that rains can also play a role of erosion with respect to the desert, and that time you might say there is no rain in the desert. So that will be a wrong statement. The right thing is yes, the rain can play a role whenever it happens. So this is something that is why I mentioned. That is how the UPSC basically picks up certain statements from your NCERTs. Now we have studied a little bit about the wind, the concepts. Now comes the aspect of erosional features, and then I will be dealing with the depositional features. With every geomorphic agent or process I will be taking up, like wind, running water and all, we will be describing a little bit, and then we will be describing what are the erosional landforms or the, let us say, depositional landforms that are created by them. This is what we are going to study. Clear? So first, erosional work of wind and the landform. So first erosional landform that is formed by wind I've mentioned is deflation hollows. You know the process of deflation. Deflation basically means picking up or lifting up of the particles that are present on the surface and taking them away because of the velocity. Now let us assume, let's see, supposingly this what is marked in red, marked in yellow basically is relatively harder rock. Let us assume this part is what? Harder rock. This is supposingly, this part is, let us say, softer. This whole part is softer in nature. Obviously, you know that because of the extremes of temperatures that happens in the desert, there will be cracks that will develop. Now what happens is when the wind is flowing, earlier when there are no cracks, there might be little erosion on the surface, but insignificant from the perspective. But as certain let us say cracks develop because of the variation in the temperature, certain particles might be present here. So what will the wind do? It will further help it. It might pick them up, and slowly picking up will lead to the softer part being eroded. Slowly what will happen, as further this process continues, further erosion will take place. Now that is why it will get deeper and deeper and deeper. That means depression formed in the desert due to the removal of sand by deflation. And you know what deflation is. So this is a absolute or a very important diagram that I mentioned that is handmade. You can just take the screenshot or pause the video and copy the content, right? Okay. Hopefully you have done that. Now this is the deflation hollows. First, let's possibly have studied also. You studied deflation. Deflation hollows is an outcome of that. Second is mushroom rocks. Now this is something very important you need to understand. Over here, the concept of sand blasting becomes very, very important. You have studied the process, sand blasting. Now see, rocks having broad upper part and narrow loose resembling an umbrella or a mushroom. These are mushroom rocks. Firstly, you should understand why they're named mushroom rocks. It is because of the shape. This upper part is broader and the lower part is narrower. That is why it is known as mushroom rock. That is first as an understanding perspective why it is known as mushroom rock. But the important thing is how it is formed. See, most of the cases when this part, let us say, is harder rocks. If it is harder rock, it is difficult for the wind also to erode it. Now, supposingly, please understand, as I have taught you over here, this was supposingly the initial surface of the, before it was formed as a mushroom rock. Now, this part supposingly is hard rock. This part supposingly is what? Hard. The other parts are softer. So when the wind carrying certain sand particles basically move, when they will encounter a harder rock, it will be difficult to erode it. But those which are softer in nature will be easier for the wind also to erode them. That is why what will happen is, when the wind supposingly is blowing from this direction with certain sand particles which they are carrying, this part is again what? Softer in nature. They will be eroding it at a greater pace, right? A greater pace. This part also, but this part is harder, that is why they're not able to erode. Further over here, this is also hard, they find it difficult to erode. What the outcome basically is that a shape of this sort is formed. This is because of, again, sand blasting processes that are taking place. And this shape, again, if the hard rock is not present here, then obviously the shape of this sort will not be formed. It depends also not only on the processes that they are undergoing, but also the nature of the rock. Over here, had the soft rock been present here, this would have not been broader in nature. That is why mushroom rocks are again ones which are broader on the upper part and narrow on the lower part. Slowly, what will happen if the erosion process goes on? This will further become thinner, and finally it will not bear the burden or the weight and will fall down. That is why when you see few boulders of a rounded shape that are present in the desert, you can imagine it that they used to be mushroom rocks probably few decades ago. So this is again an important thing. I have mentioned two more words. Now this is not mentioned categorically in the NCERTs also, but I have mentioned because this has been asked in the PCS papers and long time ago in the UPSC civil services prelims also. There is an alternative word. These are also known as pedestal rocks and these are also known as pilsfen. So now this is again very, very important. These two words are very important. Now another word is Inselbergs. Now Inselbergs is a residual hill or mounds, relatively resistant rocks in the arid region. You would have seen very often in certain arid region, these are small mounds that are present. Now other parts, let us say the erosion process is taking place. other regions, other parts within that particular region, which was softer rock, relatively got eroded at a quicker pace and they lost their existence because again the sandblasting processes that were going on that basically led to the erosional activities of the softer rocks. But there will be certain parts which are relatively of resistant or harder rock. They were not eroded properly. So now what it remains, let us say this is again a desert region. These are small mounds that are present. These are because of the harder nature of the rock and they were more resistant to the wind erosion that was taking place. That is why it appears like these small mounds that are present here. This is an outcome of the erosional activities that have been taking place in the arid region. So you can mention here or draw this also. Take a screenshot or obviously you can note it down, pause the video also. Okay, let's move ahead. Demoiselles. Demoiselles. Now, demoiselles again are very interesting features. Whenever you go to certain arid regions, you will come across these features, not necessarily in all parts of the country, depending upon what type of desert it is. Right. Now, see, represents rock pillars having relatively resistant rocks at the top and softer below. Now, these are the types of structures that are basically formed. Again, relatively eroding more of the softer rock and harder to erode the one which is resistant or harder in nature. So that is why sometimes what happens, these types of structures are formed where these are the softer rocks and they are pillar-like and some hard rock structures are present on the top. Later on, you will realize that these pillars will also erode and they will fall down, right? But these have been formed which are very unique in nature because there are like a pillars that are there and on the top there are hard rock surfaces that are present. So these are known as demoiselles. That means rock pillars having relatively resistant top as well as softer bottoms that are present and which themselves being pillar in nature, right? Okay. Please copy it down. Please copy it down. Now, next is Zeugen. Zeugen. Now see, a rock mass of tabular form resembling a capped ink pot having horizontal stratus of hard and soft rock. What happens is, bache, see, sometimes what happens, this is due to the relative erosion because of the hard and soft nature of the rocks. Sometimes what happens is these ink-like pot-like structures are formed. Some rocks are more resistant, some are less resistant. Which are less resistant, they will be eroding faster. So due to this relative erosion processes that take place, there might be an instance where such structures are formed which represent like a ink pot-like. So these structures, when you see, these are known as Zeugen. So you can just copy it down. Okay, let's move ahead. Yardangs. Now see, Yardangs. Over here, these are generally formed over here where you would see that alternative bands of hard and soft rock are present. Let us assume these yellow part are hard rocks and the white, this part is a softer rock. Obviously, when the wind is going to erode, it will be eroding this softer rock faster than the harder rock. So that is why a depression like structure will be formed because of the softer rock structure being eroded by the winds. So see here, steep sided, deeply undercut, formed by alternative bands of hard and soft rock. So this is an outcome. This was the initial surface that was there. This was basically eroded. This erosion took place and resulted in this structure. Clear? Copy it down. Okay. Now this is again two very important words, pediments and playyas. Now, supposingly, this is a rock structure, a mountainous structure where erosion is taking place and certain fine particles are falling down, right? Right? Now, see, erosional plains formed at the base of the surrounding mountain area. So, those erosional plains that are formed, which are surrounding the mountainous region, those are known as pediments. So, this is a mountainous region. Due to the erosion, there are a lot of sediment-like structure that are present here. These are known as pediments, right? So, I've drawn them also. This green color structure is pediment. Next come the word playyas. Now see here. First understand this, then I'll tell you. It is a flat bottom, low-lying desert basin. So this part is a low-lying desert basin. This is the mountainous region. Along with them, you have the pediments. You go further. Then you have a basin-like structure. Again, this basin means somewhat like a saucer shape, where this structure is present, which is known as playyas. Now what happens here is, that temporarily holds water after rainfall but usually remains dry for the most of the year. What happens is, see, pediments are present here. Obviously, sometimes when it rains, because it is a basin-like structure, so over here, playa or some water will be present here. Later on, it will dry, or automatically later on it will form like a salt pan-like structure, right? Salt pan. But when water is present over here, this is the region where water will be present. Now, this is again that is why we have said it is a flat bottom, low-lying basin that temporarily holds water when there is rain. Otherwise, it is dry, acting like a salt pan. Now, between both of them, the region that is present is known as Bajada. Between the palayas and the pediment region, the region which is mentioned is known as Bajada. So, Bajada is a region between the palayas and the pediment. This is something that you should be aware of because it can be asked in your preliminary examination in particular. Clear? Okay. Let's move ahead. See, when this is from the perspective of NCERT, that is why I am limiting here. This is basically formed by wind as well as fluvial erosional processes. Fluvial, that means water is also playing an important role. When we do the advanced concepts, possibly I can tell you the processes also and go through that. We are not going to the advanced processes with respect to the formation because that is not required, first of all, because you're not doing geography optional. You're doing for general studies. So that is why you just need to be aware what these are and what are the name and what are the definition, what is the concept. That is what you should be aware of. I can very well go into the explanations of how they are formed, but that is for geography optional students, not for general study students. Clear? Okay. Depositional work of winds and landforms. Now, over here till now, you have done all the erosional aspects. Now comes the depositional, right? See here. Quickly. Let's see the depositional aspect. Now, depositional aspects basically involve the sand dunes, the loess. These are the two major things. But within the sand dunes also, you have various types of sand dunes. Now, these questions have been asked in the prelims also. And in previous examinations, repeatedly these questions are asked. Particularly what the shape is. Now, sand dunes, when I talk about, basically refers to heaps or mounds of sand. And those mounds and heaps of sand are arranged in various ways. And because of that, they are given various names. Now, within the sand dunes, there are a lot of names which are used. This is mentioned in the NCERT also, and I have drawn the diagrams over here, hand-drawn diagrams, so that you understand it. Barchans are basically what? They are crescent-shaped dunes. Now, the important thing is, in the Barchans, this pointed edges that are present are away from the direction of wind. Now, you need to understand it is not flat. This is an elevated structure. What does this mean? This means that there is an elevation and there is a decline in the elevation like this, right? Right? So it is in this way, it is declining. If you see from the sideways, there will be a decline in the elevation. Now, wind is moving in direction and these two limbs are formed, which are again opposite to the direction from which it is coming. Clear? Now see this. Because this is the direction. So these limbs are not facing the wind. It is in this direction, right? So next thing is parabolic dunes. Parabolic dunes are reverse of Barchans. That means these two limbs are going to face the wind directly. This is also in an elevated structure in this way. So parabolic dunes are reverse of the Barchans, right? Next comes Seif. Seif. Now, Seif is again, please understand, it is absolutely similar to Barchans, but the only thing is that in a way, its one limb is missing or very small. See here, if I complete this part, another limb of this, then it will be a Barchan. But over here, do you see another limb? No. It is similar to Barchans with a small difference that the Seif has only one wing. That is the important thing. Barchans, these are Barchans, these have two living wings. This is what is a limb? This is a limb. This is a limb, right? Over here, do you see another limb? No. So, Seif are Barchans with only one limb. Otherwise, everything is same. Over there, the direction of wind is in this way and the limb is in this direction. Everything is same. The Seif is like a Barchan with only one wing or limb, right? So these are three types. Let's move to the further. Longitudinal dunes. Longitudinal dunes. Now this is what? The sand dune that is present, right? And this is the direction of wind. Now see here. These are formed when the supply of sand is poor. That means the sand that is present is of lesser quantity, right? Supply of sand means lesser amount of sand is present. And the wind direction is constant. Second, see, these are two conditions. That is why UPSC can ask you these things with respect to longitudinal dunes. Answer the following questions. They will pick up directly from the NCERT, and that particular time you'll say from where the questions have been asked. Firstly, please understand, where the supply of sand is poor, that means lesser amount of sand is present, and the wind direction is constant, that is moving in one direction only for a very long time. They appear as long and of considerable length, but not in great height. Please understand why they are in one constant long length, because if the wind is in a continuously same direction, so there's a greater possibility of them being in long length, because otherwise if the direction keeps on changing, the length will not be long, right? So this is what is the structure. Please understand this. Okay, next, transverse dunes. Now the transverse dunes are aligned perpendicular to the wind direction. The wind direction is constant. Now wind direction is flowing in this way. Now these are perpendicular. These are elevated from this side and these are not elevated from this side. In a way, if this is a structure, if I turn this, it is going to be like this. This part is an elevated part. This is where the wind is coming. So wind is coming. So this will make this particular part what? Flatter or gentler in slope, right? Okay. Next, these are the 5 types of dunes that you should be aware of. They have been asked repeatedly. They will be asked in your prelims as well as in your mains. Loess. Loess represents a thick deposit of unstratified, well-sorted, fine grind sediments. These are again very simple concept. This have been asked in prelims as one of the questions. That's loess is associated with which of the following processes. There was glacier, there was wind. So it was a very simple question. It was asked in the prelims also, right? So these are the factors which are associated with the depositional and erosional features of the wind, and the wind as a whole we have studied. Now comes the concept second, geomorphic agent, as well as the processes, because these involve a lot of process also. They are themselves agents also, because they are involved in erosion also and deposition also. And obviously they're transporting also. A glacier. What is glacier? Moving ice mass downslope under the impact of gravity is a glacier. This is something very important. Under the impact of gravity, right? So the moving ice moves downslope under the impact of gravity. It is glacier. Now please understand, 10% of the Earth's surface is now covered by glacier. This is also something that you should be aware of, because these are small tidbits which are asked in your papers also. Now we had studied the aspect of erosion by wind. Now let us see the erosion of the glacial erosion that takes place is basically from the 2 processes which are associated with it. Now these 2 processes you should be aware of. Why? Because these can be asked themselves also in the preliminary examination. First is abrasion, second is plucking. See here, let's see. Abrasion means it is a process by which rock fragments and debris in the base of the moving glacier scrape and grind and polish the underlying beneath surface. It is something very interesting. Now see here, supposingly this my left hand is a glacier. This is the underlying surface, right? Now the glacier slowly, because this is sloping downward, it is slowly going to move on this surface, right? And on the surface will be present a lot of rocks and other types of fragments, right? So that is why if you see, process by which rock fragments and debris in the base. Now in this process, basically it is going to grind them, it is going to polish them. Polish, why? Because it will make them more smoother. It might plug them also, and it is going to move further down. So abrasion is a process by which rock fragments and debris in the base of the moving glacier scraps, grinds and polishes the rocks or the debris that is present in the surface or the ground surface, on top of which the glacier is moving. Clear? Now see, plucking. Now plucking is a process whereby the moving glacier pulls away the churns of blocks and fragments from the bedrock. See, abrasion is associated more with polishing and grinding. Obviously, there are certain elements of removal also, but they majorly focus on the concept of grinding and polishing. Plucking as a process is a one, which means while the glacier is moving down slope, it is going to pick up a lot of materials from the rock surfaces or debris from the underlying ground surface. This is known as plucking. Now, when the glacier is moving, both the processes are taking place together. Plucking also is taking place and abrasion is also taking place. So, you should please note these two things down. Please pause the video and you can note it down. Okay, let's move ahead. Erosional work of glacier. Now see, if I see the erosional work or the erosional landforms that are formed, over here is U-shaped valley and the hanging valley. Now please understand this. This is a valley which you see, let us say, the glacial has, let us say, receded, right? And you see this valley that is present in very colder regions when you go, and you see how come these valleys are formed. These are valleys basically formed because of the movement of the major glaciers. Glaciers are moving down and they've eroded the underlying surfaces and all. You have seen the processes, majorly plucking also. So the cross section of the glacial valleys or glacial troughs of the mountain glaciers. So this is where the glaciers are moving. It had basically eroded this particular fragment of rocks or the ground surface, and it has created this particular structure. And this is known as what? U-shaped valley. Second thing comes, like you see a tributary joining a main river. Similarly, there might be other small glaciers will be joining the main glacier. Now, because there are smaller extent, so what happens is sometimes they are moving like this, but there's a height difference. See, this is the height difference. Because right now the extent of erosion of this particular glacier earlier on, now the glaciers have receded. Please understand. Now the glaciers are receded. Though you see the hanging valleys now, na? They have receded now. But the thing is that over here also, let us say a smaller glacier would have eroded this. And why it is called hanging? Because the U-shaped valley is at this level. The U-shaped valley is at this level. And this is approximately at this level, the base of this. So it is looking like a hanging valley above the U-shaped valley. That is why it is known as hanging valley. And this is done by what? The smaller glaciers which was trying to join the major glacier. So a valley of tributary glaciers which join the main glacier at much greater depth. So this U-shaped valley is of a greater depth. This is of a greater depth. Slowly, what would have happened? If erosion would have continued, possibly the depth would have increased, but by that time the depth of this would have also increased because this is a major glacier. So when you see this, you see a hanging structure that is formed. Clear? Okay. Next, cirques. Now please understand this. This is something very important. You should understand also. Supposingly this was a mountainous structure earlier on. Let us see this. This sort of structure was present and the glacier was moving on top of it. But you will realize that the glaciers, when they are moving down the mountain slopes also, they are eroding the mountain slopes to a very great extent. Because of these erosions, it might result in a scenario where such depressions or hollows are formed because of the glacial erosions. As I've said, this was the initial surface. The glaciers were moving on top of it. Slowly, the erosion took place. Slowly, this depression actually became larger, and slowly it reached this stage. So, this particular structure which you are seeing right now with this depression is known as a cirque. A bowl-shaped hollow formed at the head or the source of the glacial valley. It is formed by the glacial erosion where the glacial originates and accumulates. So this structure is known as what? A cirque. This is formed due to the glacial erosions, right? So this is something very important. This has been asked in the civil services multiple times. Now see, there is another very important word, erete. Erete. Now supposingly, as one glacier is moving down here, another glacier is moving down here. Supposingly, one glacier is moving down in this direction, other glacier is moving down in this direction. both will be creating their own erosional features. So what happens when two circuits cut down backward in the opposite direction? A knife edge like range is created. Now the circuits are moving down. See, two glaciers are moving down. They are eroding the structure beneath them. This is eroding the structure beneath them. So between them is a region which is basically sharpened. This is a ridge-like structure which is known as erete. It is an outcome of the erosional activities of the two glaciers that were moving down. So two glaciers are moving down here. In that process, erosion is taking place, and the part is sharpened, and this is known as an erete. Next, horn. Now please understand, supposingly this is a mountain, and here also there's a glacier, and here also there's a glacier. Let us see this. Let's assume initially supposingly this was a mountain. One glacier is present here moving down, another glacier is moving down. Slowly, again the similar thing will happen. Cirque formation will take place. And because of this horn-like structure is formed. This is known as horn. A pyramidal or triangular faceted peak formed due to the recession and intersection of three or more glaciers, cirques will lead to the formation of what? A horn. So it is not necessary 2, it might be 3, 4 also, but depending upon the scenario. So this is a pyramidal like structure which is formed at the top. This is known as horn. Clear? Okay, write it down quickly. Quickly write it down. Okay, let's move ahead. Crag and tail. Now this is again very important. This is again not these types of some of the features are not present in your NCERT, but they are important. They have been asked in a lot of examinations also. Please imagine that this particular thing is what? A volcanic plug. You have already studied a lot of landform features. You have studied the internal intrusive features and all with respect to the volcanoes, where we had told you that there are a lot of volcanic plug-like structures can be formed because of the deposition and cooling down of the volcanic magma, right? So this is like a volcanic structure found out of solidification and crystallization of, let us say, the magmatic material. Now what happens is the glacier is moving in this direction. Now for the glacier also to erode a hard rock is difficult. You know that very well. It might have eroded a lot of substances which it would have come across. Other rocks also, sedimentary rocks and other metamorphic rocks which are weaker in nature, they might have eroded it very easily. But when it comes to some of the hard rocks, particularly the granitic rocks, then it becomes difficult to erode. That is why what happens, this particular volcanic plug, now see, when the volcanic plug offers resistance in the flow of the direction which has steep side formed due to erosion is due to crag. Now, if you see over here, this particular thing is, let us say, the deposition. The glacier is moving and whatever material was present here is eroded because that was of softer nature. And what is seen or visible is this particular part, which is of a steeper nature. This is known as the crag. On the other hand, because when the glacier moves down this side, it is going to deposit the substances which had picked up earlier on. So over here you will see a tail that is formed because of the deposits that are created. This is of gentle slope. Now this is known as a tail. On the other side, being sheltered by the glacial ice becomes elongated, having gentle slope because of the deposits that have been made. Or, please understand, there is another scenario. Or, because this is basically sliding down, so that is why it is shaped in this way. On the other hand, the glacier directly encounters it, so it is in steeper form. Both the reasons can be there. Either due to deposits or because the glacier is moving down, so it will lead to a gentler slope. But over here, because it is directly encountering the volcanic plug, which it cannot directly erode because it is of harder nature, so it is somewhat a steeper nature. So this is known as the crag and the tail, formed due to the erosional features or erosional outcome of the glaciers. Clear? Okay. Ford or chford, as you can say or mention. Now this question has been asked in your mains examination also. A very simple thing. Let us see this. I made the diagram also. These are glacial troughs which have been occupied by sea. In fact, fjords are the arms of the sea which have occupied the U-shaped glaciated valleys, common in Norway, Alaska, and New Zealand. Now, please understand. Can I assume these are the, let us say, these are erites that have been formed, the glaciers are coming. Can I call this as a U-shaped valley? Or later on, this is right now U-shaped valley. Later on, when the glacier is going to recede, we can see them as a U-shaped valley, right? These are going to form later on, let us say, like hanging valleys, right? Now, see over here very categorically, when the glacier is present, this is possibly the shape or something that will be visible. Later on, when the glaciers have receded, you will see somewhat of a river might be flowing. Now, what happens is when the U-shaped valley has an ingress of the sea or the ocean, remember, this was a glaciated valley or the troughs, a glaciated valley that was present. Now the glaciers have receded and it leads to entry of sea. It might happen due to various reasons. Let us assume that there is, let us say, little bit rise in the sea level. It might not happen automatically. Supposingly, this is a structure that is present and there is a rise in the sea level. So possibly the nearby sea or ocean water might enter this and it will lead to this formation. Or due to some tectonic movements, there is little bit submergence of the continental mass or the land mass. Then also the decrease in the land mass level is taking place. So relatively the sea level in a way appears to be higher, so it will enter. This is because of the tectonic activities that take place. Because of the tectonic activities, the U-shaped valley have an ingress of the sea or the oceanic water, and this is known as the fjord, or fjord, whatever you want to call it. This was asked in the examination also, and if you had little bit detail, you could have answered it. This is mentioned in the NCERT. Now, people ignore it, and that is why they were not able to answer those 10, 15 marker questions of geography, because they ignored those minute details. Had you studied that, you would have attempted those questions also very well. Okay. Now, the depositional features or work of glacier. Now, please understand, when I talk about depositional aspects of the glaciers, there are a lot of features that are present here, which I'll show you via the diagram. Now, tills are again till is a very generic word. It is basically unstratified, unsorted debris dropped more or less randomly by glacier. So any unstratified, unsorted glacier that unsortified, let us say unstratified, unsorted, any type of deposit by the glacier is known as till. Now, this is a very generic term. Now, moraines over here are ridge-like depositional features of the glacial, and they are long and narrow. So, this is more specific because these are ridge-like structures of the deposits that were done by the glacier. Now, these are of three kinds. That is why they have been asked also. Terminal moraine, which are at the snout or the beginning of the mouth of the glacier, this region. Let us say this is the glacier present at the mouth of the glacier or snout, or the nose of the glacier is known as the terminal moraine. Lateral moraine, parallel ridges of tills either side of the glacier. This is the glacier. Now, on this side also there are certain morainic deposits, and this side also there are morainic deposits. These are known as lateral. Medial moraine, interglacial margin of two glaciers. Now, supposingly the two glaciers are moving between them. Let us see this black pen. Can you see? Now, black pen is like a deposition between the two glaciers that are moving down, right? Can you see the pen? Now, this is known as a medial moraine because it is between two glaciers that are moving down. Now, let us see these things in the diagrammatic form. Supposing this is one glacier moving down, this is another glacier moving down. One that is present in this snout, this region, terminal moraine. One on the lateral side is known as a lateral moraine on the sides. Third is your one that is present between the two glaciers is known as a medial moraine. Clear? So these are depositional features that you should be aware of. Okay, let's move ahead. Other are drum lines. Now, you see these are the topics that which can be asked in the paper also now. Now see, drum lines are again very interesting features. Many geographers have also not been able to answer the exact reasons behind it. There are a lot of books that give a different reason, so we'll not go into them. We just have to understand the features of what this basically thing is. See, when you go to certain regions of the colder regions and the glaciers are present, you will be seeing certain structures of this sort are present here. These are oval shaped, elongated, whale back made up of boulder and clay. So you will see one side, this is one side, this is known as a stoss. This is again a steeper side, and then you have another one that is very long elongated structure. So you have small, you can say it as like a mound like structure, which is from the top. If you see from the top, this is what the top view, side view. From the top, if you see, this is like an oval structure, elongated. From one side, this is the steep side, and this is again the tail. Now, this is basically because of the depositional features that have taken place by the glaciers. So, when you see in the region, you will see it is not alone present, it is present in a group of a lot of such drum lines that are present there. Today also I'm telling you there is no exact precise reason that has been found for their how they are exactly formed, but their depositional features, that is clear. How they are formed, that is not clear. So there might be a lot of such drum lines that are present. If you see it, it will appear like a basket of eggs. That is why it is known as basket of egg topography, especially when they are arranged diagonally, because when you see in a crate of eggs also, it is appearing like that if you see it from the top or even from the side. So these are basically what? Drum lines. Write it down. Drum lines. Okay, let's move ahead. Eskers. Now please understand what happens is, within the glacier also, when they are picking up a lot of, when the glaciers are moving, they might be picking up a lot of debris and all. So within the glacier also, there will be certain debris or particles that are present within the glacier, that is, it is moving. When the glacier recedes, this part basically what settles down, and this a ridge-like structure is created. A small ridge-like structure is created within this valley. So a long, narrow, sinuous ridge of sand and gravel are generally situated in the middle of the ground moraine. So in the middle of the ground, the valley that is created with the glacial or the hanging valley even, or even the U-shaped valley, you will see a small ridge-like structure. It is known as the eskers. It is because when the glaciers are moving, they had picked up a lot of particles, sand, debris, and this is in this form. Please understand. The glacier is moving down. Within the glacier inside, they have this debris, and when the glaciers recede, those particles basically settle down, and they are in a shape of a ridge. Not very tall, they might be very long, not very tall, but ridge-like structure that is formed. And this ridge-like structure is known as eskers. Clear? Okay. Waves, currents, and coastal lands. Now see, these are again very, very important aspects. When I talk about, we'll primarily be focusing on some of these currents, and because when we do the oceanography chapters, we will be covering them in a lot of detail. Please understand. We will not go into a lot of detail here because you need to understand certain concepts also, which we will be doing in the topic of oceanography. So over here, whatever is mentioned in the NCERT, that we are going to mention. See, waves. Now waves, you know that sea waves you've already heard. Many of you assume that how possibly the waves are created on, the intricacies of how the waves are, what the waves are, how they are created, and all those processes will be done in the oceanography chapter. Here we are dealing with only the landforms. So we will not go into the technicalities of those things, whether some waves are breaker waves, how they are formed, what are the processes, that is in the chapter of oceanography. Over here, we'll just study about the definitions. Oscillations of the surface water. The oscillation travel through the water, little or no transfer of water to the molecules. Now please understand, waves are basically an outcome of the disturbances that take place on the surface of the water or in the water body. If there is a small bowl of water, if you touch the water, you will see certain miniature waves will be created and move outward. Right? Now please understand, those are basically the oscillations that are moving. Water molecules are not moving, the disturbances are moving. So you see that oscillation travels through the water, oscillation motion travels through the water, little or no transfer of water molecules take place because the disturbance that is created, it is being settled down through that. On the other hand, currents are like rivers that are moving in the oceans or the seas. So a continued and progressive forward movement of water, fairly defined direction. Please understand, we cannot go in a lot of detail over in this chapter because we have to study in oceanography. We will just focus on the features over here, right? Okay. Erosional work. Now see, supposingly this is this region over here is the sea. And obviously the waves are going to come and they're going to crash against the coastal region. Let us say this is a rocky coastal region. Now what happens is, this is supposedly the initial surface. When the waves crash, obviously it will be, a lot of force will come, it is going to erode it. So there will be certain structures will be created. Now if you see, this particular part has flattened because the waves keep on coming, and this smoothing of the surface takes place. This is known as a wave cut platform. The region where this is a lagbhag almost a parallel surface that is created, a tall elongated parallel straight surface that is created adjoining the coast. This is known as the cliff, and below the cliff you realize there is an undercut that is here. This is known as a notch. So if we see a very steep rocky face adjoining the coast, this is the cliff. Undercut at the base of the sea cliff, this is a notch, and rock cut surfaces in front of the cliff, this is a wave platform. This is done by the erosional work of the waves. So this is a small diagram that you should be very well aware of. Okay, let's move ahead. Let's move ahead. Sea caves. Now let us assume this. See this very well. This is basically again this is all water here. Here, sorry. Sometimes you will see in the oceans that this structure will be coming out and protruding out. Earlier on, this was actually one part. Slowly as the erosion takes place, this will basically form such structures. How it is formed, please understand. Let us see this. Supposing that this is a part of land on the part of the coastal region which is rocky in nature, certain waves will be splashing around the sides, from this side also and from that side also. So a hole might be created. A hole might be created. Now this hole or a hole like structure that is created is known as a cave. Now such hole is being created from the other side also by the waves. What happens is, let us assume this is a structure. From this side also wave is crashing, from this side also wave is crashing. Hole will be created here, hole will be created here. After some time, what will happen? Both will basically merge with each other. So what will happen? This is a point where now water can basically come and go from this side. So first process is creation of the cave. Post the process of creation of cave, the erosion continues. So this part will be continuously eroded. This part will be continuously eroded from that side also, this side also. So in a way, this arch-like structure will later on form. Arch-like structure will later on form. Now, please understand, supposingly the erosion continues even now. The size will possibly increase, and possibly this particular part will fall down. So what will remain is this part. Later on, from erosion continues, it will create smaller part and this thing will be created. So what I'm trying to say is, this was earlier the same structure. Due to erosional activities, this landform is basically moving back. So when I'm talking about sea caves, these are prolonged wave attack on the base of the cliff, creates holes in the regions of local weakness. So because of the waves, these holes are created. These are known as the caves. From both the sides when the holes basically meet each other, it creates a arch-like structure which is known as a sea arch or arch. When the two caves approach one each other and unite to form an arch. So this is an arch. Later on, when this arch falls, this will become an individual structure and we will study this. These are known as stacks. These are known as stacks. Clear? Okay. Let's move ahead. Depositional features. Now please understand, these are small features that you should be knowing. See, beach, you should know, temporary or short-lived deposit that of marine sediments is known as a beach. Let us say this is a small beach over here. This is a landform, this is a beach. So basically beach is an outcome of the deposition that takes place, that is brought by the obviously the waves, obviously the currents that come. So these are deposits by them. So these deposition on this side of the coast is basically known as a beach. So these are short-lived because modification continuously takes place. Now, these small deposit of the sediments, this is known as a sand split. If it is in a form of a hook, it is known as a hook split. If there is a small island and this is the main, let us say land, and this is the island. If that island or a land mass is connected with the main land through a depositional feature, this is known as a tombolo. This is known as a tombolo. And obviously, if this internal waterland is separated, or let us say a depositional feature is there, this is known as a barrier island, which is separating this particular piece of water body, or a lagoon also. So this is known as a barrier island. So these are the depositional features associated with the waves, and which we are going to study in detail in the oceanography chapter also. Next comes karst topography. Now this is something very, very important and very interesting also. This is generally not taught to the students. Students do not study them, but this is very important from the civil services examination also. Now, when I talk about karst topography, this basically refers to the chemical weathering processes that take place in the region where limestones are present again, right? So these are landforms produced by chemical weathering or chemical erosion of carbonate rocks, mainly calcium carbonate and magnesium carbonate. Or calcium carbonate is CaCO3. Calcium carbonate is CaCO3. And magnesium carbonate, which is known as dolomite, by surface and subsurface water. Now over here, the role of the surface water as well as the groundwater plays a very important role in creation of such structures which we are going to see. So these are landform structures that are formed by the chemical weathering processes when the chemical erosion of the carbonate rocks takes place, particularly the calcium carbonate and the magnesium carbonate, because of the surface and the subsurface water. This is known as a karst topography. Now see here, there are certain essential conditions that are important. Now this can be asked in your examination directly, in your mains examination and in your prelims examination also. Now please, just before I explain them, see this very well. These are the structures which you're going to see also. Supposing that this is a huge landmass, before anything was created, these are beds of limestones that were present here, right? Calcium deposits that were here. So these are, if there are a lot of joints that are present, water can seep through them. So a lot of things you need to understand. When I'll explain them, I'll come back to this again, a hand-drawn diagram, because certain essential conditions are important. If they're not fulfilled, you will not see such structures being present everywhere in the world. Why did this karst structures, you are very commonly seen in former Yugoslavia, because from there the word karst has come up, because all the conditions are being met there. So if you want to see such structures, which is a representation of karst, and over here depositional features also you'll see. This is within, inside, and this is again outside. So what are the essential features for that? The thing is, limestone must be massive, large. That is why you can see large structures. Thickly bedded, that means a lot of stratas are there, and well joined. So these all features are very important. Position of limestone should be above the groundwater. If it is below the groundwater, obviously everything can be dissolved and such structures might not be formed. Limestone is widely distributed both in the aerial and vertical. That means it is great size or a larger size. Carbonate rock should be present very close to the ground surface so that rainwater may quickly infiltrate into the beds. This is an automatic obvious reason. Limestone should be highly folded, fractured. So when it is folded and fractured, it basically leads to a lot of formation of infiltration, and where the water is infiltrating, along with a lot of new landforms which we see over here, can be very easily created also. So these structures can be formed because they're faulted and fractured also. So ingress of water through the rainwater becomes relatively easy also, because to the joints certain fracturing is done, so that is aiding the process of creation of the karst topographic structures. there should be enough rain. If there is not enough rain, so from where will you get the water? Again, subsurface water will be impacting to certain extent, but rainwater is again a very, very important feature. So these all features which I mentioned here, 6, are essential features for the karst topographic structures to be formed. If these features are not present in regions, in spite of the fact that limestone is present, you will not see such structures. That is why you see that in spite of the presence of limestone in various countries, such features are not present everywhere because of the non-presence of the following or the above mentioned features. Let's move ahead. Erosional features. If you see such structures over here, you will be seeing in this structure, you will be seeing something known as lepes. Highly corrugated rough surface of limestone lithology characterized by low ridges and pinnacles. In these karst topographical regions, you will be going through regions where a lot of pointed things are present of limestone. These are known as pinnacles, which are top. So this structure which we see over here is known as lepes. If you see, this is a surface. This pointed things are pinnacles, and this rough surface which we see over here is basically referred to as lepes. Sinkholes, swallow holes, dolines, collapsing, ovalas, and polges. Now, this is something very important because these are more to do with, let us say, the size also, relative sizes. Sinkholes, chemically active water dissolves limestone carbonate and forming small holes. Now, what happens is, because water dissolves in the limestone over here and small holes are created, and these small holes are like these sinkholes. This is a small sinkhole that is created here, right? Now, after the sinkhole, you say there's a concept of swallow holes. Closely spaced sinkhole combine to form a larger hole. Now, if few sinkholes are together, they together combine to form a larger hole. So that means it a outcome of the combination of a lot of sinkholes that leads to a larger hole, which is known as a swallow hole. So can we say this is a larger swallow hole? Possibly what would have been here? There would have been one sinkhole here, one sinkhole here, one sinkhole here, and together they just combined and a larger hole was created, which is known as a swallow hole. Clear? So this is another statement. Next, dolines. Swallow holes may further enlarge into large depressions form dolines. Now, dolines are larger depressions when you compare it with what? The swallow holes. So can we see here? So where are the swallow holes? Dolines. Dolines are here. Dolines are much larger than the swallow holes. So you can say very large size swallow holes can be known as a dolines. Now, when we move further, collapse sinks. Solution holes formed to collapse of the upper surface because of the formation of cavities. Sometimes what happens is the fall of the upper surface because of the dissolution process is known as a collapsing. So solution holes formed due to the collapse of the upper surface because of the formation of cavities below the ground surface. Now, this is again we will be seeing in the internal processes also. Over here, please understand, every word that is present over here becomes important because this has been asked. These 2 points have repeatedly been asked in the mains exam, prelims examination also. Now, when we talk about ovalas, ovalas basically refers to extensive depressions up to 1 kilometer across. So that means a huge area, very large area, much more larger to an extent that it might vary to 1 kilometer in, let us say, length. So those are known as ovalas, and much larger than ovalas are the polges that are even larger than them. So when we see over here, see, ovalas are much larger, and beyond them below are the polges. Clear? Polges. So this is being represented over here. Clear, everybody? Done? Okay. Now comes the caves. If you will see, there will be again certain structure that are present. Because of the limestone structure, there will be certain holes or cave-like structures that are present there. You will see they are void of large dimensions below the ground surface. So these are large structures that are present below the ground surface. These are known as the caves. These are known as the caves. Now, vertical pipe that connects the cave. Now, this is a cave, and these are pipes that are connecting the cave. These are known as ponors. These are known as ponors. Clear? Okay, let's move ahead. Depositional features. Briefly, you should know and understand them also. See, slowly as limestone is dissolving with water, this small droplets will be going down, and this will solidify. These are known as stalactites. And after the water droplets are dropping down, they will be collecting here and they might form a structure over here also. These are known as stalagmites. Stalactites and stalagmites. How you will remember? Stalag G for ground, that means from the ground level it is rising. These are other stalactites. Sometimes both these features combine to form, supposing this is moving down, this is moving down, they combine. This is known as a pillar. There can be a group of stalagmites over here, which are known as compound stalagmites, and this is a cave floor. Obviously, there can be a cave pool also because the water has assembled over here. So this is known as a cave pool that is present inside. Okay, see here. Stalactites formed by the deposition of calcareous solutes which are carried by water dripping through the cave ceiling, formed by the deposition of calcareous solute formed on the clay fold. Pillar when the stalagmites and stalactites basically join, as I've explained you. Okay. Okay, now running water. Now please understand this. Running water, when I'm talking about, is a very, very important perspective over here. We all know what running water is, but there are certain concepts which I would like to explain to you, because this is a very, very important part and integral part of your conceptual clarity of running water. You know that very well. Now see here, let's see. You know that there are various stages present, right? Young, mature, and old stage. When the river is basically moving down from the mountainous regions, you will see a lot of different landforms are created, right? As you just at the start of the mountain, you see, you will be seeing V-shaped valleys. When you go to the mature field, you should be seeing U-shaped valleys, and so on and so forth. We already know that also. We study that also in our schools and colleges. But the important thing is, we know one fact is that when the river is moving down, this river is eroding, right? Right? Agreed? But the question that arises is, till what level will this erode? Supposingly, a river is moving down on certain surface, let us say any region also. You say the river will be moving and it will be eroding the sides also, particularly the grounds also, the bed also, the river bed, which is known as a river bed. To what extent it is going to erode? This is a question that has always come across many candidates and they're not able to answer it. Please understand this. That is why the concept of base level comes. This is something that you should understand. You know that this river over here will like to erode. Do you realize everything that I mentioned here, all these three things? The river in these stages, relatively, yes, obviously the erosion will be more, greater tendency, greater force, here will be very less, minimal. But river in these stages relatively would be eroding the ground, or let us say the river bed. Till what level it will erode? So that why the level till which the maximum level, or the level till which the river will erode is the base level. What is the ultimate base level? The ultimate base level is a sea level. Can a river erode beyond the sea level? No, because that is the maximum extent that it can erode. Now, locally also you realize the groundwater at the local region. Now, if I'm standing in some region of NCR, Now sea is very far off, but do you realize there is a concept known as groundwater? Now groundwater is present. Groundwater also acts as a local level, base level for us. Beyond that, the river will not erode. If the groundwater level falls or the local base level falls, the river will further start eroding because it wants to again meet the region of the base level, so that lesser energy consumption takes place. So in order to achieve that, it is continuously going to erode. Now, water surface, please understand, local base levels play a very, very important role. That is why in the regions of Kashmir, you will be realizing that though it is in the mountainous region, various rivers are meandering. Why are they meandering? Because of the base level, local base level aspects that are present here. Now, please understand, the local base level is again associated with the ground level, but the ultimate base level is the sea level, beyond which the river will not erode. So, the ultimate base level sea level. Groundwater influences the local base level. This is something that you should understand. If supposingly due to some reason groundwater level rises, the erosional capacity of the river around that region will decrease. It will not erode further. But if that base level falls down, it will again start eroding till the level it reaches the base level. So this is the concept of base level that you should understand. The ultimate level, base level, is the sea level. Local level is obviously influenced by the local factors and obviously the groundwater present at that particular region. And that marks the erosional ability of a particular river also. Now, if the base level over here is, let us say, further moves down, more erosion will take place. That is why you realize finally when the river merges with the sea, that is the ultimate base level that ends. So till any river reaches the base level, whether it is a local base level or the ultimate base level, which is the sea level, it will try to erode. It depends upon the erosional ability, depends upon what is the speed, what is the velocity, what is the nature of rock, type of rock, how it is jointed, what is material it is made up of. All those factors influence. But tendency is this, which I've explained you. This is something that you should be a little bit aware of and something that is important. Clear? Now comes the aspects of erosional features as well as the depositional features by the rivers. If you see the river valleys, if you are in the young phase of the river, you will see there will be V-shaped valleys that are formed. When you go to the mature phase, you will be seeing the U-shaped valleys are formed. So, river valleys again are a long, narrow depressions on the earth's surface which have been carved out by the erosional activities of a river over the time. Yes, so this is basically known as the river valleys. So, this is basically present in the young phase. This is present in the mostly in the mature phase of the river. When you move further, waterfall. Now, waterfalls are created because of the erosional activities. Now, please understand, a lot of erosion is taking place. Now, what is waterfall? Waterfall is a steep descent of the river or stream over the vertical and nearly vertical drop in the course. So, this is again over here, please understand, a drop in the course is taking place. There are a lot of other features through which a water fall can be created. It depends. Now, let us assume hypothetically, if supposingly this was the original topography, and supposingly erosion has continued and slowly, let us say certain parts have been eroded which were a softer rock. Now, because of that erosion, now water is falling from certain level. Slowly, this will further erode backward, and which is softer rock will further be eroded. So, there are waterfalls can be of 50 categories, but some of the other way you can say they're related to the erosional activities. Now, slowly, when this erosion will take place, supposingly this will end, this will further fall. So, this waterfall is again it basically refers to the steep descent on the river or river stream over the vertical, where nearly vertical drop in the course takes place. With this aspect, please understand, at the base of the waterfall, there is a pool that is created, that is also by the river because of the force which it is falling. This is known as a plunge pool. Over here again, movement of particles take place. So it is a deep circular broad bowl-shaped depression that is formed at the base of the waterfall. This is also a erosional feature that is present. River terraces. Now please understand, river terrace is a very important aspect. These are terrace-like, step-like structures that are formed. If you go to Grand Canyon and all, you will be seeing such step-like structures will be formed where a Colorado River is moving, right? How does this happen? Please remember, initially this was the surface. The top was the surface. When there is further fall in the base level, erosional activities will increase. Further base level will fall, so further deep cutting will increase, and this is the level where it will reach. So please remember this. This is basically referring to the erosional activities and how the base levels have changed, and that is why this was the initial surface, right? This was the initial surface on which the river might be moving. Let us see here. Let's see here. This is the original surface. Let us make a simple diagrams for you to understand. Supposingly, a river is moving on this flat surface, right? Now, when the river is moving, it is eroding the surface. When it is eroding the surface, automatically, what will be the next step? If supposing the base level further falls, this is the path where it was eroding. Now, this is a staircase because of the erosional activities, that are taking place. This is the meandering action because of which it will further move down. And because of this, this part will appear elevated. What? This part will appear elevated. Now, further, if you see further the base level falls and further erosional activities continue, what will happen? Further it has gone. So such piers are created. This is because of the erosional activities and the meandering action or zigzag movement of the river. That is why. And along with it, yes, as the base level moves down, further that will provide more energy or better as a potential for a river to more erode more the ground surface, and that is why it will move down and such terraces will be created. So in either side such terraces are created. These are known as river terraces because of the erosional activities. Next, incised meanders. Now you have very well known what is meandering of river. You see, the meandering of rivers generally takes place in the old stage because at that time you realize that the steep slope is no more present and the speed at which it is flowing also is very less. So that means load is more. So that is why there is meandering of river that is taking place. Now, when the meandering of rivers take place, the problem that arises is that in certain cases, such type of structures will be created, particularly when the region has a rocky terrain. So what can happen is, see, if it is in a rocky terrain where river is meandering, but you will see that it will lead to it basically cutting the rocky surface also. So this will be known as an incised meander, right? A meander or river bed that is deeply cut or entrenched in the bedrock or valley floor due to the downward erosion of river. Now, please understand such types of structures, if you see in certain regions in Europe and even in the Kashmir region also, there are certain parts where this is visible because the rocky terrain is present. Obviously, that is influenced by the local base level. If you see in the deltatic region, obviously it is not very easy to be found unless and until there are coasts which are associated with rocky type of coast are present. Only then it can be visible. But otherwise, if you see, these are basically representation of the fact that there is an imprint of the movement of the river on the rocky surface because of the meandering action influenced by the local base level. So this is known as incised meandering. Clear? Depositional work, natural levees. What happens is normally when the river, this is like the river flowing through its channel. When the river is flowing through its channel, you will realize that it carries a lot of sediments also. Sometimes when it floods, the level rises, so the sediments are deposited on the sides. Now, these deposition on the sides are known as natural levees, right? See here. Raised embankment made up of coarse sediments, mainly sand and silt, that form along the both sides of the river channel due to repeated flooding and deposition is known as natural levees. Please write it down. All of you write it down. Write it down quickly. Done? Okay. Now, next, delta. Delta. Delta, you know that very well, associated to the coastal regions where you see that deposition of a lot of sediments take place in the final stages. Now, this is supposedly a river and deposition is taking place in the form of delta. Now, the depositional features almost in a triangular shape at the mouth of the river that is entering the lake or a surface or ocean or a sea. So, this is known as a delta. Now, because delta word is derived from a triangle, it is not necessarily triangle, it might be of various shapes, various types. Deltas themselves are of various types. So, this is just a representation over here. Next is the concept that is present in your NCERTs is an alluvial fans and cones. Now, what happens? Due to the accumulation of material at the base of the foothill, there is drop in the channel gradient. Now, sometimes due to the steep drop in the channel gradient, the rivers that are carrying the sediments are deposited just at the base of the foothills. Now, they can be seen in the form of a fan, that is why they are known as alluvial fans, or sometimes a cone-like structure is formed, alluvial cone. The difference between them is alluvial fans are associated with gentle slope than cones. So, the fans, alluvial fans will have a gentle slope, cones will have a sharper slope. Alluvial cones will require more debris, but fans will require relatively lesser debris. So, these are again two which are mentioned in your NCERT, so we have covered them. Clear? Okay. These were the important factors or the features that we have done over here, and hopefully you enjoyed them. Hopefully you learned a lot of features. Obviously, there are certain other aspects also which are associated with the oceanography and all. We're going to cover them in the chapter of oceanography and deal with the ocean's currents in that particular chapter. So, whatever you have learned them, I will request you to please revise them properly, understand them well. These are very, very important from the perspective of your civil services examination. All the diagrams have been made by hand. So, please continuously revise them and make the best use of it. Take care, and as we say at the end of the lecture, Jai Hind, all the best, and do well in your examinations also, and make the best use of this particular lecture. Bye. Take care.